Dynamic Dialogs is a feature introduced in Genero 3.0 to let you trim code and simplify maintenance for common routines. A typical project contains a lot of repetitive code. Code to perform database table maintenance and table lookups are examples of coding patterns repeated over and over again, where the only differences are the names of the database tables and columns and the business rules. Take a moment to consider your current project. If it has 200 Zoom lookup routines, then you most likely have 200 open window statements, 200 for eaches, 200 display array statements, and so on. If you use the Dynamic Dialog feature, this can be reduced to one open window, one for each, and one display array. With only one set of code to worry about, the code becomes easier to maintain. If you want to add some code to these dynamic routines, you only need to add it in one place, not 200. This is the benefit of using Dynamic Dialogs. You can use Dynamic Dialogs to implement a generic Zoom window to select a record in a list. You can also create a generic single table maintenance program and use dynamic dialog techniques to control forms generated at runtime. Methods from the UI.dialog class create dynamic dialogs at runtime. This allows you to create a user interface dialog where the number of fields in the dialog is unknown at compile time. Instead, the runtime system builds the dialog dynamically from your selected inputs. To reference the dialog objects, you will declare a variable with the type UI.dialog. Create a dynamic array with a record structure using two members to define the field name and data type, as shown here. Your code is then responsible for populating this array with the names of each of the fields in your dialog and the data types to be used to store the values. The data types are provided as strings. Techniques to populate the array may include reading from a data dictionary to get the names of columns in a database table, or reading a form to get a list of columns. Once you've populated the array with a list of field definitions, create a dialog and pass the dynamic array to it by one of these three methods to create the appropriate dialog. Use UI.dialog.createInputByName to create a dynamic dialog handling simple record input. Use the createDisplayArray2 method to create a dynamic dialog to handle a list. Use UI.dialog.createConstructByName to create a dynamic dialog to handle query by example. You can then add user-defined triggers to the dialog using the UI.dialog.addTrigger method. Now that the dynamic dialog is defined, you use a while loop with the UI.dialog.nextEvent method to handle dialog events until you explicitly exit the loop with an exit while. You can explore the DB browser application provided in the FGLDir demo directory to learn more about dynamic dialogs. It shows how to create a dynamic dialog to perform table maintenance, as well as techniques to build and manage a dynamic form for the dialog. The application first uses a static dialog instruction, displayArray, to display the list of tables in the stores database to a predefined form. The user picks a table from the list and clicks Browse to open a new window and form with options to insert rows, delete rows, and perform query by example to filter the results set. This is the part of the application you'll want to focus on. It's implemented with dynamic dialogs and dynamic forms. To understand how it works, open the dbbrowser.4gl source file and start at the top. First, a dynamic array is defined with the two members to define the field name and data type. The user picks a table from the list and clicks Browse to trigger the accept action. The action handler then calls the Browse Table function passing it the selected table. The Browse Table function defines a variable of type UI.dialog and calls the Describe Table function. The Describe Table function uses methods from the base.sql handle built-in class to create dynamic SQL to populate the dynamic array with the names and data types of columns in the selected table. This information will be used when creating the dynamic form to display data from the table. The Browse Table function then calls the Create Display Array Form function to create the form for the dynamic dialog using the UI.WindowCreateForm method and methods from the OM classes. Once the form is created, a string variable is defined with table selection criteria, and the UI.dialog.createDisplayArray2 method is used to create a dynamic dialog object, a display array to display data from the selected table. Browse Table creates the user-defined triggers with the UI.dialog.addTrigger method and calls the FillArray function, passing a reference to the current dialog, the string variable containing SQL selection criteria, and a selected table name. The FillArray function creates dynamic SQL from the SQL string variable passed in and uses methods from the base.sql handle class to open a cursor and fetch the results set. Finally, Browse Table implements the body of the dynamic dialog using a while loop and the UI.dialog.nextEvent method to handle user interaction until the user selects Done to exit the dynamic dialog and close the window and form. If you'd like to see a more complex example of a dynamic dialog, have a look at Ruben's example called FGL Zoom, available from GitHub 4J's Genero. This example uses dynamic dialogs to create a generic lookup routine, sometimes called a zoom or query, which refers to the window that appears when you click on a Button Edit button to select a value from a list. You can explore it in detail, but essentially all these zoom windows are passing through the same library routine, written using dynamic dialogs. You can view any code that's unique to a particular routine by clicking the View Source button. This is the unique code for the zoom window for state. For this zoom window for country, this is the unique code. And here is the unique code for the zoom window for customer. Ruben's dynamic dialog example demonstrates a dramatic reduction in source code, as well as a consistent look and feel for zoom windows in an application. This translates into increased profits as these applications take less time to develop and maintain.